Hello. Hello, could you hear me? Hello, could you hear me? Yes. Great. Sorry for that. So I'm going to share my screen. Great. Sorry for that, and we're going to start soon. All right. So sorry for all the technical issue for this. I'm going to start this presentation. First of all, welcome to my talk. This talk is about why derive a password. My name is Xiaoyi Li. I'm a senior Android developer at Dashlane. First of all, I would like to please allow me to give you some brief about Dashlane. Dashlane is a password manager to store and manage your password securely on COS platform. Dashlane is the app that makes the internet easier. Dashlane fill all your password, payments, and personal details whenever you need them, across web on any devices. Dashlane securely store and autofill your password payments while you are browsing on the web. Our goal is to provide the best security along with the best user experience to our users. As Android developers, security matters in Android development. With the rapid growth of Android devices in the world, security has never been as important as it is today. Cryptography on Android is one of the most important subjects. Imagine you have some content to keep secret, so you want to encrypt it. Here is a general system of encryption. You have your password, you have your plain text, so you pass it into the encryption function, for example, AES-256. Then you generated your encrypted content. In this system, you are pretty sure your plain text is secure. But how about your password? This is our topic to focus today. Is it secure of your password? Today, we are going to talk about several subjects: insecure usage of password, and as we are not using password directly, we are using password hashing, but the hashing can be cracked. And we were going to talk about how to survive and prevent from those password cracking and the implementation on Android. Passwords created by humans are usually very short, and users reuse that password for different online services. And users created those passwords could be predictable. Some example of simple and bad password, for example, 12345, 111 passwords. I hope you are not using it. As on the software development side, storing all users' password as clear text is unsecure. If you store the password in clear text in your database or software, it can result in massive security breaches if the password file is compromised. If an attacker gets the access of the password file, then it is stored in plain text, then it doesn't need any cracking. Using the password directly is also risky if you are using for encryption or authentication. On this system, the attackers can crack the password by brute force attacks or dictionary attacks. Basically, guessing the password and trying the password in every possibility. Once the password is cracked, they can access the plain text, or they can reuse this password for the other services. As we are not using the password directly, so we use password hashing. Let's see what is password hashing. Password hashing is a one-way function that has the fixed size defined by the system. The same password will has the same output if they are configured as in the same parameters. There are some well-known algorithms such as MD5, SHA-1, SHA-2. Standard cryptographic hash functions are designed to be computed quickly, and as a result, it is possible to try guessing password at a very high speed. Common graphic processing can even try billions of passwords per second. even though password hashing is a one-way function, there are many ways to recover the password from the hash, which is called password cracking. We will discuss a bit some common solution about password cracking. What are how the hash are cracked? There are several different common solutions for cracking: brute force attacks and dictionary attacks, lookup tables, rainbow tables. Brute force attacks, basically the attackers will try every possible combination of character up to a given length. These attacks are very computationally expensive, but they will always eventually find the password. Additional attacks use files contain words, phrase, common password, or other strings that are likely to be used as a password. These dictionary files are constructed by extracting words from large body of text or Wikipedia database, or even from rare database of password which has been leaked before. Lookup tables are basically pre-computed tables that store the hash of the password. What does it mean, a pre-computed table? So additionally, that contains possible password and compute the hash of each password and store them into a database. For example, you have a column hash and a column password. Once the cracking starting, the attackers can just searching the hash in the database and can easily find the password. The third thing is called rainbow tables. Rainbow table is a time memory trade-off technique. It uses a pre-computed hash chain. We don't have time to go into very detail of this rainbow table cracking solution, but there's a comparison table for this. Brute force attacks will take large computation time but small space in the computer. But lookup table, it will take large space on the devices, but very small computation time because it just needs to search. And rainbow table are both adjustable for time and space, depends on the attacker's hardware. So there are so many ways to crack a password. How can we survive from a password cracking? All defense are about increasing the cost of the attackers. Attackers usually has different and more powerful hardware than us, and attackers can even use different hardware architecture, allow certain algorithms to run faster on common hardware CPU. And certain algorithms can be parallelized. To make the password cracking harder, what we need to do is increasing the cost. The cost contains two dimensions. One is called space, one is called time. Let's take a look one by one about space. Increasing the space by the sort. So lookup tables and rainbow tables only works because each password is hashed in the exact same way. The attackers can pre-compute a large number of password hash or rainbow tables to crack the password by searching in the pre-computed table. We can randomize the hash by appending or prepending a random string called sort to the password before hashing. The sort is not a secret value. You can save this value into a shared preference database or storage on the devices. For example, software can prepend a random string or byte before the hashing. The sort randomizes the output of the password hash, make it impossible for an attackers to store tables of password and pre-computed hash because the output are always different. There's some common mistake when using the sort. The first one is called sort reuse, like no sort. So using the sort can make the current rainbow table useless. But if you're reusing the same sort, a new rainbow table or pre-computed table can be generated if that sort it is found by the attackers. And using a single fixed sort for different user also means user who input the same password will have the same hash. For example, in this table, Alex, John has the same password and they will have the same hash in the table. This will make it easier to attack multiple users by cracking only one hash. Another mistake is using a very short sort. So the attackers can just create a rainbow table that consists every possible sort. However, sort doesn't prevent brute force attacks. It just ensures that attackers can use specialized attacks like lookup tables and rainbow tables. But it doesn't prevent them to run brute force attacks on each hash individually. High-end graphics hardware like GPU and other special custom software can compute billions of hash per second. So these attacks are still very effective. On GPU, it can even be faster. To make these attacks less effective, we can use a technology called key derivation. The idea is to make the hash function very slow so that even on a fast GPU or custom hardware, dictionary attacks and brute force attacks are too slow to be worthwhile. In the meanwhile, this delay should not be noticed by the user. Of course, we don't want slow logging in the software. So just give you a concept of how this slow hashing can defend. Here is a general system of using key derivation to increase the cracking time. Still, you have your password, you have your plain text. We will do a key derivation of this password to generate a derive key and use this derive key in the encryption system. So let's take a look about the key derivation. Key derivation function, which is called KDF, it takes a password as a sort and a cost factor as an input, then generate a password hash. The purpose is to make each password guessing by an attacker who obtain a password hash very expensive, and therefore the cost of guessing password is very high. As we can see in this function, key derivation function takes the sort into account. So it provides a good defense for the lookup tables and rainbow tables. And the cost can be memory cost, thread cost, time cost, etc., which can make the hash very slow. So now we already know key derivation is the solution to defend this modern password cracking. So how the key derivation function is like and how is it work? We will discuss how to implement that in on Android. So key derivation function, there's a built-in function in the framework API, which is called PDKDF2, which is called password-based key derivation function. 2 is a common use algorithm to derive key material from a passphrase. So Android framework provides an implementation of this algorithm inside the secret key factory package. There are two algorithms which is building. The first one is called PDKDF2 with HMAC SHA-1 since API level 1 and PDKDF2 with HMAC SHA-256 which since API 26. Just would like to show a simple example of the code. So basically, we will have defined the parameter iterations. Basically, is the cost of the time. The more iteration you have, the slower this function will run. And you will call the API to generate the key. Be careful here. You will have to handle migration because the user can upgrade their device from an old version of OS to the newer version of OS. However, with the growing use of massive parallelized hardware such as GPU, FPGA for brute force attacking, and has made the selection of a suitable algorithm even more critical. PTK-DF2 has been out there for a long time, and it is easy to parallelize on multi-core system. Next, we will see what we can do even more secure on massive parallelized platform. More secure key derivation on Android, which is called Argon2. So a good algorithm should not only enforce a certain amount of computation costs on CPU, but should also resist the cost performance advantage of parallel platforms such as GPU and FPGA. Different algorithm has been designed for specifically for this purpose. Let's take a look how it is on Android. At Dashlane, as a password manager, we take the security of password as top priority. We choose Argon2 as the default key derivation. Argon2 is the winner of the password hashing competition. And of course, this is not supported on any version of Android framework. The source code of Argon2 is a pretty small implementation in C language. You can compile it for Android architecture that you need. Or you can use other wrapper library like ListOfDoom, which has some Java JNI binding library available for you. ListOfDoom is a modern and easy to use software library for encryption, decryption, signature, and password hashing. It is not a good. It is not a bad idea to use a wrapper library if you need other cryptographic function. But if you are doing security critical things, it will be worth it to try compile the source code from you, so you have full control of it. Let's take a closer look on the Argon2 API. So Argon2 is parameterized by a time cost, which is the first parameter, which defines the amount of computation realized and therefore the execution time, given the number of iterations. And the second parameter is called, it will define the memory cost, memory usage. And the third parameter, parallelism degree, which define the number of parallelized threads. Therefore, we can see it is not only constrained on execution time, but also take the hardware condition into consideration, which will provide better defense on special parallel hardware. To implement those Argon2 algorithm on Android, we will use NDK system. So here I will give you a recall of how NDK system works on Android. So basically, you will have your native you have your Java code or Kotlin code, and you have your native C and C++ library. Between them, we will need the JNI to iteration and communication. So first, you will define your native interface in Java code, and you will compile the Argon2 source code or ListOfDoom source code based on the target Android architecture. For example, you have the ARM64 and x86-64 architecture. Then you will define the JNI export function to be called from Java, which is, so this system is very traditional JNI system. In the end, I would like to recall you the whole system of this key derivation. So you may remember this graph, insecure usage of password. So use the password directly in the encryption system is insecure. What we want to do on the system is that always do a key derivation on the user's password to generate a derived key, and use that derived key to the encryption system. Finally, there are some takeaways for security for you. First, don't write your own crypto function, so we don't do stupid things. and don't use the password directly, use the derive key. And when you are doing the hash, you should use the sort and a long sort, and don't reuse sort for every user, at least each sort for each user. And we should also keep away from insecure algorithms like MD5 and SHA-1. The attackers can always upgrade to more powerful hardware to crack your system. And the defense of the security will never stop. What we can do is to stand on top of the security and always increase the cost of the attackers. Your users are entering the password into your application. So if your database or application get hacked and your user's password is unprotected, then the user can use those passwords to compromise other services and websites of the user. So it is not the security of your software or your company, but also your users' security. So we are responsible, as a software developer, we are responsible for users' security. So I think that's it for this talk. I have put my contact link. You can reach me on Twitter or Medium for any further question or any other discussion. And I think we are good to have some time for the question. Let me just check. So we have some question, few questions. I hope you can see. So the first question is, if sort should not reuse, how can I check if the user is using a good password? So basically, a sort is not reused, but a sort is not a secret value. So basically, you get this sort from the storage. Then the user will enter his password, which you don't have. Then you will use these two, the password and the sort, to go into the key derivation function with the correct parameter you defined it in your software. Then it must generate the same hash. In this case, you will know the password is good. I hope that answers your question. And let's see the second one. Have you already faced at Dashlane a security issue with your user password, and how did you resolve it? That's a very good question for Dashlane. So basically, when we are talking about users' password at Dashlane, we mainly talking about the master password at Dashlane. So the master password, Dashlane never have them in Dashlane. So it is only the user that has them and input them. And about the user's website password, which is the personal data for the user. At Dashlane, we have a zero knowledge architecture to ensure that Dashlane doesn't have the access and control and usage of this personal data. So basically, a security issue about the user's password never happened at Dashlane, because on the architecturally, it prevents this. So let's see the next question. Have you used the Android key store, and what's your opinion on this? I think Android key store system is a pretty good system when you can provide the built-in security for this. Basically, if you want to do a simple, if you want to do a pretty basic security storage, you can use the key store system, because the Android key store system for now, with a newer version of updates, it also associate with some hardware security protection inside. So I think it's a good idea to use this. To ask the next question, to ask the sort reuse question differently, what is the best way to pick a password for each user? So basically, this question is what is the best way to generate a sort for each user? There's no secret of generating a sort. So in the Android framework, you have the secure random function, which can generate a random byte array for this user, and it is secure. So try to use the secure random API to generate a random sort for this user. And because it is randomly generated, so it is not predictable. It is long enough. So that's already a very good way to pick a sort. Next question, does two-factor authentication essentially eliminate the risk of password of brute force and random table? The password is not enough for access. That's a pretty good question. Basically, we have how can we say? We have when we are using password, we are using password for authentication or encryption. So basically, for authentication, yes, it is secure to authenticate user because it requires user action to get into the system. But for encryption, I think it is not enough because it also depends how you deal with this two-factor authentication, because you should encrypt your content with the password and the key from the two-factor authentication to make sure your password is your content that encrypted with this password is secure, and your password won't be cracked easily. Next question about Agong2. What are the good value for the time cost and memory cost and parallelism to keep a good application performance? Good question. So everything should be tested For example, you are developing mobile software, so you will try different parameter on different devices. For example, you pick the oldest device, a very old device, to try different parameter. For example, time cost, which is the iteration, it can be 2 or 4. Memory cost can be 1024 megabytes, and parallelism degree can be 2. So the idea is that basically you won't have a big latency for the user's login. But imagine you have increased 500 milliseconds of hashing time for each user. This is already a very high cost for the attackers. But 100 milliseconds or 500 milliseconds on old devices, which is acceptable. It will be faster on newer devices. Next question, how should we store the keys on Android device securely? So basically, if you want to store the keys locally, you can use the key store system, which already provide a good protection along with software and hardware on the devices. I think that's great. I'm not sure if you have more questions, but anyway, you can always reach me from Twitter or Medium, and I uploaded my slide material on this conference page. Feel free to reach me on media channel, and we can have further discussion. And thanks your time, and I hope you learn something from this talk, and enjoy the Android Maker and the rest of the day. Thank you. Bye bye.